to True Projects. In this video, we are going to discuss about the project, which is tomato leaf disease detection. So before getting into the execution, first let's understand what is the project about. So a critical aspect of agriculture, that is tomato cultivation. So tomatoes, they are vital crop, but they are highly susceptible to diseases that can significantly impact yield and the quality. So these tomatoes, they are staple in our diets and they are major income source for many farmers. But here the problem is diseases like bacterial wilt, early blight and viral infections. They cause severe damage which leads to the economic loss as well as it threats the food security. So detecting these tomato leaf diseases early, it is very important so that farmers they can take actions quickly, they can prevent diseases spread and minimize the damage. So accurate diagnosis, it ensures the right treatment is applied, avoiding wasted resources and future problems. So typically disease detection relies on visual inspection, microscopic analysis and chemical tests. While these methods they can be effective, they are often labor intensive, time consuming, often inconsistent. They can be subjective and inconsistent, and they require skilled person and resources, which makes them suitable for that is unsuitable for large scale farming operations. So advances in machine learning, they improve the accuracy, that is they have improved the disease detection, but these methods they still faced significant challenges. That is machine learning models they often relied heavily on manually extracted features which can be limiting. So there is a risk of models performing well on training data, but poorly on new and unseen data. So these models they can be computationally intensive, requiring substantial resources and more advanced techniques such as deep learning with pre-trained models. These models they can automatically learn features and improve accuracy, but they still require significant computational resources and fine tuning to generalize well across different data sets. So deep learning with pre-trained models provides a more advanced solution but requires significant computational resources and fine-tuning to achieve the generalization. So to address these limitations, our project focuses on using the ResNet 50, which is the model of CNN, that is the family of CNN, that is convolutional neural network. So we are going to use ResNet 50 with different activation functions and kernel sizes. So these activation functions, they play a crucial role in neural networks by introducing non-linearity, which enables the model to learn complex patterns. And coming to the kernel part, kernel refers to the size of the convolutional filter used in activation functions, which determines the area of the input image each neuron processes. So this project's aim is to develop a more accurate, efficient, and scalable method for early and reliable detection of tomato leaf diseases. So by refining these advanced techniques, we aim to provide a solution that can be widely adopted, helping farmers to better manage their crops and reduce losses due to the diseases. So moving on to the implementation of the project, first we have collected the data and then we have pre-processed the data. That is, we have pre-processed tomato leaf images. So we have did augmentation, we normalize the images. And then we modified ResNet 50 model by experimenting with different activation functions such as ReLU, leaky ReLU with different kernel sizes, that is 7 by 7 and 11 by 11. So this helps us to assess their impact on the model's accuracy as well as efficiency. And then the modified models, they are trained on the dataset, that is tomato leaf dataset with optimized hyperparameters to ensure the best performance. And then we have evaluated the model. So by using accuracy, we have evaluated all the models, that is ResNet 50 with all the different activation functions and with the different kernel sizes and selected the best configured model. And then we have deployed that model in the front end. So we have used Flask framework to build the web application, which is integrated with the SQLite database. So we have used Flask framework to build the web application, and SQLite is integrated with the Flask framework for the database purpose. Moving on, these are the algorithms which are used. So here we have built ResNet 50 with the ReLU activation function and kernel size of 7 by 7. And the next model is ResNet 50 with leaky ReLU activation and the kernel size is 7 by 7. Last we have is ResNet 50 with leaky ReLU activation function and kernel size is 11 by 11. So the model, that is the configured model which performs well, will be used for the final prediction. Moving on, to implement this project, we need software and hardware requirements. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So this is all about a project. Now let's execute it. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of a project. Let's understand each of them. How will they be used in the project? So here in the first folder, that is the data folder, we have dataset that is used in the project. So open it. Here we have two subfolders. One is train and the other one is test. Coming to train folder, here we have 10 subfolders. So these are the 10 different types of tomato leaf diseases, that are 10 different classes that we will be predicting. So in the first folder, we have tomato disease, that is tomato leaf disease of bacterial spot. So these are the images related to bacterial spot. Similarly, here we have early blight disease in the tomato leaf. And here we have images of healthy tomato leaves. Here we have late blight. Similarly, we have in other folders also. So we'll be using all of these folders, that are the images in all these folders, for training the model. Coming to test, here also there are 10 different classes. So we'll be using all these images to evaluate the model. So we'll be using train folder to train the models and test folder to evaluate the models. Get back. Here we have model file, that is model folder. So in this folder, we have the algorithm information. This will be loaded into the project code during runtime. And here we have static folder. So this folder contains files related to project styling and interactivity, which includes CSS, JavaScript, and Bootstrap files. So these files are crucial for enhancing the visual appeal and functionality of the project's web interface. Next we have is templates folder. So here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure, layout for displaying content to the users. And here in the test cases folder, we have some of the images of different tomato leaf diseases. We'll be using as a test cases in the front end to detect the diseases from the tomato leaf. Get back. This is the app.py file. This is a Python file which encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And this is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes a popular choice for the data science. And the last file which we have is signup.db file. This file is a database file which is used to store the user information. So these are all about the files in the code folder. Now let's execute it. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. Here we can observe that current directory is changed to the code folder's path. Now compile the app.py file. So give the command app.py and then click on enter. Sorry, we have to give the command python space app.py. Now click on enter. So this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and now click on enter. So this is the web page of the project, which is displayed in the browser. And this web page is built using Flask framework. So to execute, we need to sign up first. So click on sign up link and enter all the registration details if we are registering newly. I have already registered and I have an account already, so I'll directly sign in. So click on sign in and give the username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. So here we can see a choose file button. We need to click on that for uploading the tomato leaf disease images. So click on choose file. So here are some of the tomato leaf images. So I'm uploading the first image, click on open. Here we can observe that image is loaded. Now click on predict. So based on the uploaded image, here we got the prediction as tomato bacterial SS spot is detected. Let us upload one more image. Click on home, click on choose file. So let's upload the third image, click on open. Here we can observe that the image is loaded. Now click on predict. And here we got the prediction as tomato leaf mold is detected based on the uploaded image. And the given input image is recognized as the abnormal, which results the leaf is suffering from the tomato leaf mold. Let us upload one more. Click on home, click on choose file. So now we will be uploading the fifth image. Click on open. And here we can observe that image is loaded. Now click on predict. And here we got the prediction that tomato yellow leaf curl virus is detected, which results the tomato leaf is suffering from the yellow leaf curl virus. Let us upload one more. Click on home, click on choose file. So now we'll be uploading the sixth image. Click on open and now click on predict. And here we got the prediction as same that yellow leaf curl virus is detected from the tomato leaf. Let us upload one more. So now we'll be uploading the eighth image. And here we got the prediction as tomato leaf is healthy, which means the leaf is completely normal. Now let us upload some more. So I'm selecting the 10th image, click on open, and here we can observe that image is loaded. Now click on predict. And here we can observe that tomato leaf mold disease is detected, which means the leaf is abnormal and the disease name is leaf mold. Let us upload one more. Click on choose file. So now we'll be uploading 10th one. And here we got the prediction as same leaf mold is detected. Let's upload some more. Upload the 11th image. So here we got the prediction as tomato septoria leaf spot is detected, which means the leaf is abnormal and it is suffering from the disease called septoria leaf spot. So now we will upload one more image. Upload the 13th image. And here we got the prediction as tomato spider mites, two-spotted spider mite is detected. That means that tomato leaf is abnormal and the disease name is spider mites, two-spotted spider mite. Let us upload one more. Click on choose file. So let's upload the 17th image. Click on predict. And here we got the prediction as tomato target spot is detected, which means the leaf is abnormal and the disease is target spot. So now click on log out, that is sign out. In this way, just by uploading images to the system, the application, it will detect the tomato leaf diseases using the algorithms that we have built in the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.